So peer reviews are due tonight. And that means that I am looking to see from all of you a score, well, 2 scores for each person, yourself and everyone else in your group, effort and technical contribution. I tried an announcement on Canvas to try to give you a sense of what effort looks like and what technical contribution is. Effort is just effort. If they're trying, if they are communicating, even if they weren't able to get much done, if they said, hey, I'm having a really tough week, maybe a family member is in the hospital, or there's something that is weighing on me. My job has really forced me to lock down and spend more hours than I would like, and I haven't had as much time to focus on this project as I would like. As long as that communication is there, some combination of what they've been trying to do with the project and their communication, how well are they interfacing with the group? Obviously, that can't be an excuse forever. So at some point you are expecting this person to step it up, but we all are human and things happen to all of us. So allowing for a short period of my life is hectic is probably something that you should all assume that each other is going to experience at some point this quarter and treat them like a human. So that effort and technical contribution is what they're actually contributing to the project. So the idea is that if you feel like you are horribly unprepared for the technical part of this class, if you are doing your best to interface with the class and catch up to the best of your ability, learning, researching on the side, contributing what you can, then you would score very high on effort and moderate to moderately high on technical contribution, and that averages itself out to a passing grade is the idea, that you're only going to fail this if you are not trying and or your technical contribution is 0. So the effort should be a gimme as long as you're doing your best. And it's really hard to score below a 70 if one of 2 components is perfect. So that's why that is built in, is to prioritize effort. And even if you don't feel like you're 100% there technically, that's okay. You can still do all right. So that's due tonight. If you score anyone below a 10, please include a bit of a reason for that. Again, that's not trying to make you do extra work. It's just for my data collection. If I'm going to reach out to this person and say, the group is not seeing whatever it is that you may think that you're producing, let's open up a dialogue with them and try to figure out what they're expecting or why there's a difference between how you see your contributions and how they see your contributions. And give you an opportunity to work on that and communicate with them. And if I see that kind of progress, that's another scale that I build into the final grade, is if things are improving over time, then I won't harm you as much in the final version. So there's reason to continue to improve as well. Tomorrow is our client meeting. There's also going to be a presentation by Fast Enterprises in the first 10 minutes. You've probably seen them before, and or they go around to quite a few classes and have about a 10-minute presentation. So client meetings, I'll be pulling a group at a time with a timer into probably this room where that's going to be happening. Whatever group goes first doesn't have to watch the Fast Enterprise presentation. I don't know if that's a benefit or a detriment, but I will let you decide. I will need one group to go first though.
Is there a, do you have a time?
Yeah, so we have, what is that, 90, 80 minutes for the 2 hours. So it's 110 minutes divided by 7 groups. So it's about 13, 14 minutes per group. Yeah, including transition times, it's probably going to be about 13 minutes. 12 to 13 minutes. So I will have a timer running for that. And when time is up, which means that you need to have all the information. So think about preparing in advance to get all the information and feedback you can from the client. That is going to improve your usability and your eventual grade on your first sprint. And you also need to save time for and get information about the second sprint from the client so that he can communicate his expectations for you. So it's not just data on the current version of the project, but you also need to know what you are implementing. If you don't get that in terms of clarity, I'm going to be giving you some requirements in terms of the technical requirements, but there is the ability for what happened in that comic on the first day of class to transpire if you don't understand correctly what the client wants. And that might not be caught until you try to write some user stories and you start development and someone comes back and says, this isn't what I asked for in a user story. I'll try to be a little bit nice about that this first time, but by the end of the class, I will expect that you have the ability to ask the client questions, get the information you need so that you can go implement what the client wants. Questions about the upcoming schedule? We have sprint 1 due this Sunday night. And we'll be starting sprint 2 the following day. Another 2-week period. It just starts to fly.
And we're doing the GUI in sprint 2.
Yes, yeah, GUI will be a requirement the client will tell you about. I will give you that hint from the future. But yes, they will want some kind of graphical representation. Do not worry about that before Sunday. Try to get what you have working. Any other questions? All right, I'm gonna kind of blow through this presentation a little bit faster than I would otherwise because some of you have seen 212, some of you have probably seen this slide deck that I wrote before. But from what I could tell yesterday, from talking to people and looking at people, it looked like there could be a reasonable amount learned or gained from going over testing at a bit of a higher level, as well as diving into the exact syntax of unit tests in JUnit. So I figured I would pull this out of the graveyard of 212 and deliver it in here. And I feel like I'll be doing that a lot in the future as 212 becomes a thing of the past and people don't have that experience coming into this class. So this and design patterns I'm incorporating into this version of this class so that we get a sense of actually using some of these tools that you talk about in that class. So motivation for testing, I sit down, write a small program. How do I know it works? What do we mean by it works? We talked about this a little bit with regards to testing. It would be amazing if I could map every possible input to every possible output and get some kind of green check mark that says my program does what I wanted to for all of those inputs. How would we be able to determine that? If I write a single test for a single output, is that enough to validate that it works in general? Depends on the problem. If I write 2 tests, if I write 10 tests, when do we know how to stop? Or when to stop? The answer to that is just when writing additional tests does not become worth the time. Every test, if we're prioritizing them from most important to least important in terms of functionality, how many bugs they're showing in some capacity, then you start writing the tests that are the most important. And eventually there becomes a threshold where the time it takes to write the next test is not worth the amount of information that you gain from having written that test. But oh no, I realized that I forgot to implement a couple fairly trivial components. What about the tests that I'd already run, verifying what the program did before I made those changes? Does the program still work on those same outputs, or sorry, on those same inputs, producing those same outputs? We don't necessarily know unless we go back and try them, especially if these fairly trivial components interact with existing code in some capacity. So yes, the idea would be that you have to try every input-output case after every change to make sure that your program still performs at the level that you thought that it did. So if this seems time-consuming, it is, and there should be a better way for this. As you're developing these programs, you're making changes to your GitHub every day. So it would make a lot more sense to embed the tests inside of GitHub so that when someone makes a commit, you're automatically running every test that you've written historically to make sure that a base level of functionality defined by the tests that you've written is still there in your program. And you have proven that with the tests that you've written for it. So we don't have time to identify all of the issues with your program manually after every time we commit those changes. So this is mostly stuff that we've talked about. So again, I'm gonna fly through. I'll stop here a little bit, talk about how possible it is to completely test a system. If you're going to do this, you probably need some kind of mathematical proof associated with your program, and we will talk about that a little bit later on in this course. Probably we'll spend a day or so on formal verification and how do you use logic and math to prove that your program will work for every possible input in general. This is something that can be done, but is very tedious and very difficult, especially for large programs that have lots of interconnections. So usually what we do is an approximation of this, which is write unit tests for particular input-output pairs for the most vital components of the system. We've talked about how bad bugs can be. There are some more recent examples of bad bugs that using slides that I've written more recently. So the T-Mobile data breach of 2022 had 50 million users having personal data leaked and stolen. A lot more examples of very large data breaches since 2022. That's happening more and more frequently. Tesla had 135,000 vehicles recalled for touchscreen memory issues, which can be a bit of a problem. Airbus had a A400M crash and kill everyone on board in 2015. You know that there have been plenty of other airplane crashes due to faulty software. So unit tests, we talked about smallest unit of granularity, tested on some small module, some small system. So think about it running on an object and testing a particular behavior function of that object. So some method that is a part of some object. You want to make sure that that method does what it's supposed to, given some state of the object. So you're going to set the associated fields to be a particular internal state. Then you're going to call the method. And that method, if it works correctly, given the input that was the state of the program, is going to create a state of the program afterwards that the only change that happened between the beginning and the end was that this method ran. So you're isolating anything that could have gone wrong to this process. You're manually going to set it up. You run the method and you check the results, and you know that logically, if the program were in this state and these lines were run, then the resulting state should be this. And if it is, great. If not, there's something wrong with the method. So in Java, we use JUnit. Other languages have other testing libraries, but no programming language worth its salt does not come prepared with the ability for you to write tests for it. For every class you write, you should also be writing a paired testing class. So do not embed the tests in a single file. Do not embed the tests in the file that you are testing. There should be a separate test file, and you should write one for every class that you include in your project. Yeah.
Is this exact requirement that you're talking about required for the sprint one?
It is not. You're starting testing requirements in Sprint 2. So nothing that we're talking about now is required. I try to do this in general where there are big design things that you need to be focusing on. I try to talk about them before, a few days before the sprint is due. Otherwise, yeah, you would all hate me.
Get him.
So yeah, pair your classes with test classes. So if your class's name is foo, make a class called foo test, and that's where you're going to store all the tests that are written about the foo object, all the methods that are part of the behavior of the foo object. Every method you write in foo test is a test case that sets up a particular state of foo by modifying its fields, then runs a method in foo to test the functionality of that method, and then again looks at the state of the foo object afterwards to make sure that that foo object looks the way it should, given that the method ran when foo was in that initial state. As you write larger programs, there are going to be interconnections. You're going to be calling methods that are outside the scope of this foo object. As this happens, you're still going to write in foo test something that tests what foo does when it communicates with something else. Those are integration tests. What does JUnit allow you to do? We should take a look at that list. So everything that is done is via some kind of assertion. And these assertions are how you tell whether you got what was expected or not. If the assertion passes, that means the value that the test got was what the programmer said it should have gotten, in which case the test succeeds. So you can make a test succeed by giving it the value that your program outputs, whatever your program outputs, whether it's intended or not. So please never do that. That makes this completely useless, worthless, doesn't tell you anything of value about the actual behavior of your program. So those of you who are using IntelliJ can just go to this link. I put this in 2.12 because everyone was using IntelliJ in 2.12. But regardless of what IDE you are using, there are easy ways to interface with JUnit. Just make sure you import it, you set it up correctly, you add your associated dependencies so that you can, it syntactically recognizes JUnit tests and can run JUnit tests.
If you're using a VS Code, I can help out and give you a couple of pointers on how to get that set up.
Okay, yeah, if you're using VS Code, talk to Yoko. All right, important imports for any test class. org.junit.star. Static org.junit.assert.star. As soon as you have that, you're good. So just make sure that every method header looks as such, and then you can start writing a test for it. Use the @test to signify that the method that follows is a unit test. So @test is flagged as a test case, great. All test methods run whenever JUnit runs your test class. So as you make this file, you're going to eventually be able to run this file. And as you run this file, it will just run all the tests that are associated with that class. And now you have an easy way to determine the output of all of your tests given the current state of your code, which is great. So next you might want to ask what assertion methods exist. What can we actually do with JUnit tests? We can assert true, which means that the output to this test is a Boolean expression, and we're expecting the output of that Boolean expression to be true. If it is not true, the test fails. If it is true, then it succeeds. We can do the same thing with assert false. It's still a Boolean. The output of that method is going to be some yes or no, true or false, but we now are expecting that the output is false. For assert equals, it takes two parameters, some expected and some actual. The actual is going to be hard-coded by you. Sorry, the expected is going to be hard-coded by you, and the actual is going to be what your code runs. So then you're comparing basically on a dot equals level for that. So note that there's a big difference between assert equals and assert same. This is exactly the same thing as you would compare between equals equals and dot equals in Java. How familiar are we, or how do we feel about the difference between equals equals and dot equals in Java? Those of you who aren't giving me a thumbs in any direction, I'm assuming is down. All right, so it looks like people have a solid handle on that, which is good. So if you would in your code want to write dot equals comparing objects by reference, then you should use assert equals. If you want to assert that the values of them, so at a shallow copy level are the same, then you want to use assert same or assert not same. You can assert null or assert not null as a way of determining whether an object has a value or whether it is empty, which is very useful if you want to go run a method on an object. You could first query whether that is null or not, or that an object should be null at a particular time or not null at a particular time. If the object is null before it tries to run for some reason via some test case, then you can see that in your tests before you have some kind of critical failure in your application. Note that assert equals also takes an optional string at the beginning that is the message to display if it fails. This is very useful in your tests to identify which test failed, what it was trying to measure, and what likely happened as a result. So let's take a look at some examples. So here is an array initializer. So the first test is going to initialize the list, add 42, -3, and 15 to the list, and assert that the first element of the list.get of 0, returns 42. It'll also assert that list.get of 1 returns -3, and that list.get of 2 returns 15. You may assume that this is just going to succeed, but that's why we write these tests. If this doesn't work for some reason, something horribly wrong happened. Can anyone think of why this test might fail?
The add function is
Yeah, if your add doesn't work.
somehow you ran out of space in your linked list for lessons, yes.
Sure. Ran out of space, allocated memory in some form, sure. So there are still reasons to do even basic functionality tests like this. You could also write a test is empty, another thing you might care about. So we're gonna make a list. We should be able to assert true that the list.isEmpty returns true. If that returns true, then we succeed, stating that when we make a new list, it is empty. Once we add something to that list, we expect that it is no longer empty. So assert false should return true, that the list is no longer empty. When we remove that one element that was there, we should be able to determine that this was empty again. So this is a 3-test unit test. Usually I like them to individually be in different tests, because if you do something like this, and this test fails, which one of the 3 elements broke? We don't easily know. We have to run kind of subtests at that point to determine that. So this should really be written as 3 separate tests, where each one fails, you can tell directly from the test that failed what happened, and you can reproduce it. So how do we do this? Every other IDE will have something similar to this, but in IntelliJ, you just write your test class, and then once you've done that, you can just run the individual methods within it, or the class as a whole to run all of the associated tests within that. So next thing I might want to talk about is solid testing. Whatever the word I'm trying to think of is.
Practices?
Yes, exactly that. Sometimes English fails me and it's really funny. Basic words that you should be able to come up with. So yes, I see this all the time in job as programmers. If you write your tests in order to pass, we are not looking for passing tests. We are looking for a program that does as much as possible with the fewest bugs possible. So your tests should be written to identify bugs, not to pass. So goal of testing is to write tests that are most likely to fail and reveal bugs. Think of it like on a homework that is worth 2% of your grade, followed by an exam that's worth 98% of your grade. If I give you a bunch of useless assignment pieces that are all repetitive, you're not going to learn a bunch from that, and it might not show the actual breadth. But you could show, hey, look, I got 98% on this homework. It's just that 98% of the problems were all identical or all very similar to each other, and they did not represent the breadth of the content that is going to be on the exam. So how well you did on that homework is not going to be representative of how you perform on the exam. And an argument as such wouldn't go so well. I understood 98% of the content here. It's just writing a bunch of useless tests. My program passed 98% of the tests. Yes, but when a user goes to go use your program, how frequently does it crash? You want that to be related to the quality of your unit tests, the extent to which you've done your unit testing. So you want to spend a lot of time in the test design process to reveal those bugs. If you are writing tests to pass or writing tests just to do the basics and to do it due diligence, it will waste your time. The only way that writing tests is going to be valuable is if you are spending the time to critically think about what it is that you are writing tests about. So if the test can't fail, it doesn't have a particular important failure point that you can identify, worth the time to create. If your program is testing valuable output, so typical use, something that is critical to its infrastructure, those are going to be more valuable tests than those that are testing edge functionality. There are quite a few failure points that can fail in different ways, and you want to try to isolate those with different tests. Each test should test a single point of failure to whatever extent possible. And you will find that you will need to write entire test suites, lots and lots and lots of tests, to thoroughly test even simple programs. So let's spend a little bit of time thinking about this. So here is a date class with the following methods. Have people seen this before who took 212? Does this look familiar? Yes, I thought so. All right, so come up with tests to check that no date object can ever get into an invalid state, and that add days works properly. So those would be the two things that maybe your boss comes to you and says, I'm interested in the associated functionality. Please write tests that do this, that make sure that this object adheres to these constraints. So take a little bit of time to think about it. If you've thought about it before and came up with it, try to recall what a good answer to this was.
The input can be a string.
In which case,
In the date, it all has to be integers.
right. So a year is an integer, a month is probably 1 to 12, a day is probably 1 to 31. So how could we ever have a date object that's in an invalid state? How could I create an object that could potentially get into
Any of the parameters are null
an invalid
or
state?
negative.
Sure.
If there's-
So I have the ability to set a date, to call the date constructor and pass it a year, month, and day. So we would want to make sure that there are checks in that constructor. So what happens if I pass in a month or a day that is out of bounds? What happens if I set it to be February 28th on a non-leap year and add a day?
Should go over to March.
It should go over to March. If it is a leap year, then it should not. So there would be ways to get into an invalid state if we ever reach something like February 30th. So we want to make sure that it's not possible to get to a February 30th. We would want to make sure that we can't get to a February 29th on a non-leap year. If you've tested that for a particular non-leap year, do we know that it works for all non-leap years?
You can't go to the past.
We don't know. We don't have access to the code. All we have is the API. Note that you can write the tests without access to the code. You can test this without looking at the source code at all, by just looking at the API, seeing what you can call, and logically thinking about how could a date object get out of place. Is leap year always return the correct answer? Does that matter for when you add a certain number of days? What happens if you try to call add days and pass in a single day, a negative amount of days, a more than a week, more than a month, more than a year?
Overflow.
Yeah, how do you handle any particular call to this? Does it get into a state that is not allowed? There are lots of ways, lots of potential bugs in here that would allow for that state. So if we're checking for that, there are lots of tests that we would need to write just to make sure that a date object can't get into an invalid state. Lots of ways. This has not been thorough. My analysis is just off the top of my head. 5, 6 ways we could get into an invalid state. How about that add days is working properly? I kind of alluded to this a little bit. You can pass this some pretty fun things. What if we pass add days with 0? What do we expect? Get back the same day?
You're not adding anything.
Yeah. What if I pass it -1? Are we going back in time?
Must be positive.
Either we expect it to return some kind of failure, or we expect it to subtract days. If we overlap a week, does it roll over correctly? When we query the day of week. If we roll over a month, does that roll over correctly? If there are 30 days in the month, if there are 31 days in the month. Should we test every single month? Because maybe there's a bug where someone thought that September has 31 days. We wouldn't catch that if we tested every other month, but not September. So you can imagine that there are tons of tests that you could write. The question is, what is the granularity where the tests stop becoming worth the time to write? So we're going to write a couple of tests, and I want you to criticize these tests.
Here.
Yeah,
Well, some of these like for the seeing that it's saying 2015, 2 and 15, and then sort of equals it done a get day in the first test. So
yeah. So we're certainly testing that the day should be 19. Is that the day that we want to test for? That's a good point. It would be okay that that test returned false, but we would prefer to test the day that it actually is. The 1 and 2.
Bad test names.
Bad test names. Test 1, test 2. We don't like that. Yeah, name your tests something that they're actually testing. Excellent.
For test 2, I feel like, yeah, adding days, trying to like add that to February and expected it to be March, we should make sure that that'll actually add up to the correct day, could be 29. something like that.
Sure. In 2050, is it a leap year? It's not.
The other thing is, there's a lot, like, especially in like the first test, there's like multiple certs that you're not really gonna check realistically. Like, you're like, oh, I'm gonna check the year still 2050, when that's not really what you're testing. You're testing that you're adding days is gonna change from 15 to 19.
No, there's still something to be said about making sure that that didn't change the year, because if it
Yeah.
did change the year, that would be adding a single line like that to just ensure that nothing changed from that you don't expect to change is probably worth the single line. That is a good point, though.
But having that in the same test though, it might fail because it did change the year.
Right.
How would you know that?
Right. Yeah, it probably should be tested as its own separate. When we add days within the same year, the year stays the same. That's fair. Did anyone notice that the expected and actual were flipped in the first test? Yeah,
Yeah, that's what I was thinking about.
yeah. That's a really tough one to catch, but that is one that is expected and actual are supposed to go expected, actual, not actual, expected.
What that test even?
How about messages? What is this testing? What is test 2 testing? You actually have to look at the test code to figure that out. So you could do something like this. So on the first hand, we expect the expected to be before the actual. And test cases should certainly have messages. And now we can test 3 things in the same method where we know which one failed by year after plus 14 days. We'll print associated with 2050 what we expect and the actual year. So you would see if that did not actually adhere and maybe it added a year. Let's say year after plus 14 days, 2050, 2051. You would see exactly what went wrong. Next thing we might want to talk about is the associated readability of unit tests. So you want to make sure that your tests are readable and that people can parse them as quickly as possible. So the prior tests now are significantly more readable because even though it's a little bit longer in terms of the code, in case of test 1, we now state that the name of the variable of the date is now expected. So now when we assert equals, we are comparing the expected date that we set manually to the actual date that was calculated by setting a date and adding the days. Now we're comparing two date objects that we manually created that should be equivalent based on the add days functionality. That's the only thing that has changed between the two dates, is that add days was called. So it's easy to read, it's easy to tell what's being tested, and it's easy to see exactly if something is wrong, right where that issue would be. It's in the add days method. Does that make sense? That you just create an object called expected, and that way you can compare expected to the calculation of the actual that utilizes the method that's being tested. We talked about this already as a flaw. Don't name your tests arbitrarily, name them something that actually is regarding what they are testing. You want as much description of the test in the name of the test as you can possibly get. So something like add days within same month 1. Add days wrapped to next month 2. Something like this will allow you to, within the name of the test, when it say this test fails, you know exactly what it's testing just from the name of the test. So much easier to read, so much easier to figure out if it fails, what happened. We immediately know which test, what the issue is, with an English description that is the name of the test. We can write good assertion messages, very important. So here's an example of a bad assertion message. Why is this not great?
It's too verbose and it's on multiple lines.
It's verbose, it's on multiple lines, I completely agree, both of those are problems. There's still one big problem with it. Does it tell you what the test did? The assertion message has nothing to do with the actual test that was performed. So we should have something like adding 1 day to this expected actual. It is much more succinct. It gives you a nice summary of what we did. And we see that expected should be 2/16/2050, and actual, if it deviates from that, we can see everything that we need about the test just from the assertion message. Very quick, right to the point, and we see what the test tested. We don't have to look back at the test to figure out what the test was written for. If you didn't have that and just had should have gotten expected, but instead got actual, and you see that test fail, you have to look back at the unit test to figure out what the test was testing. What was the initial state? How can I reproduce this? All of that is embedded only in the test. And instead, if you have this, everything you need is printed as part of the error message. You do not have to go find your test in your test suite and read it again. So you can also query an amount of time. So testing something like a loop that may be infinite, you can set a timer. So again, we have some bad and some good, but here's exactly how you would do it. Just set an associated timeout equals a number of milliseconds. And better would be to factor it out into a static constant that you can easily change, because it is one of those hard set numbers. So now we can easily change the timeout for all tests that time out with one change. If I want to change from 5 seconds to 2 seconds, and I have a bunch of tests that are testing an associated amount of time, if I set that timeout equals 5,000, then I have to Control F, try to find all of the places where I made that constant, and instead, here I can just set the associated timeout. If you want different timeouts, make a short timeout, medium timeout, long timeout, but factor all of that out into static constants, saves you a ton of time, effort, headache. So timeouts are very good to use on tests just in general. They should time out after some period of time. If your test is not succeeding and you run your test class and it just starts to spin and you don't know which test timed out, just throw timeouts on tests. It can't go too wrong. So instead of writing out each one as a separate timeout, make a default. And you can just now make a timeout equals default timeout and use a static constant for your default timeout. And just include that on every test that you write. And now if a test ever fails to complete, you know and get an associated error message from that particular test. Sometimes you expect your program to crash in a particular way when you do a particular thing. There's no easy way to recover from that, but you want to make sure that your program is crashing and providing feedback to the user in ways that you would expect. So you can make an expected equals exception type dot class, and this tells you exactly which exception you expect this test to throw. Test passes if it receives that exception and fails if it does not receive that exception. So you can test for anything that an exception would test. As an example, you can get an array index out of bounds exception if you make a new array list and then try to get something before you have filled the array list with anything. Every one of those values should be out of bounds because its size is initialized to 0. You try to query something that is at or above its size, it should return an array index out of bounds exception. If it instead gives you a null pointer exception because you somehow didn't set the array list correctly, then this test would fail. We can have code that runs before and after each test case. So you can use, I think this, did this change between JUnit 4 and JUnit 5? I recall this for some
Before
reason.
each and after each. now.
Yeah, there's also a before each and after each. I feel like there's a difference between them. Oh yeah, yeah. There's before class and after class and before each and after each now. So that has changed between JUnit 4 and 5. So yeah, at before each and at after each will run that code before and after every single individual test. And before class and after class will run just as setup for all of the associated tests and then tear down for those associated tests. In general, don't try to test every possible input. Don't try to test every possible parameter. Think about how much time you have to devote to testing. It should be probably about as much as your implementation time in general, but then you're going to prioritize the associated tests that you run. Think in general about boundary cases. So if your program takes, if this method takes an integer input, think about where in this code is there an if this value is greater than some other value, and test values close to that boundary. So instead of having to test just a few things that are above that boundary, test something above that boundary, close to that boundary but above that boundary, close to that boundary but below that boundary, and below that boundary. And those 4 tests will be the most likely to fail. Once you've done those 4, writing an additional 5th test for that becomes less and less worth your time to make sure that this works correctly. So if you have something that maybe tests for positive, negative, or 0, those should be the 3 tests that you write. At the edge of an array's size or a collection size, if you have an array list, check to make sure you're not getting an index out of bounds exception on the last element, or that you are getting an index out of bounds exception on the first element past the size. Where a Boolean expression changes value, so when something was going to be true but is instead false, where is that decision boundary? Test things right on that boundary. Empty and error cases, so null, 0, -1, empty list, empty array. Behavior together. If add works, that's great, but does add work right after remove? Does add work right after remove when remove the last thing from the collection? Make multiple calls to the same method. Maybe size only fails after it's been called the second time. It works the first time, but the first time somehow changes the internal state where the second call does not work correctly. That'd be some strange behavior, but it could happen. What's wrong here? The hint is in the name.
Torture test.
Yes.
It's torturing the date.
Yeah, everything is wrong here.
Day. Add days. Add 365 days. If days less than days per month. Add a day.
So logically, this works, right? It's going to successfully test this. But what are some improvements to this that we can make?
It kind of feels like this is like its own method that are, like, this could also have problems with the way they set something like this up. So
Yes.
you wouldn't want something like this in a test.
Right, if you can make bugs or have bugs in your test, that's not good, because then you need tests for your test, which is beside the point. We do not want to get that level of meta. Yeah,
Also, would it just be easier to test the edge cases? Because at a certain point, checking the dates between February 2nd, February 3rd, and February 4th is gonna be kind of redundant.
yes,
So you can just test the rollover dates between the different months of the years.
yes, there are significantly more tests than there need to be in here. Let's say this fails. Torture test failed. What do we know? Absolutely nothing. We have to go through a long convoluted process that's the equivalent of making more tests to figure out how this test failed. So test one thing at a time. So if you have 10 smaller tests, way better than one large test. That means when the one large test fails, why did it fail? We need to write 10 small tests in the moment to figure out why the one large test failed. Each test method should have probably only one assert statement. If you have more than one assert statement, have a reason why you have more than one assert statement, and a way to distinguish if this test fails, which assert statement was responsible for that failure. You should be able to determine that from the message. If you assert multiple things, the first failed one stops the test. So that doesn't mean that the second one and third one were correct. It just means that we failed on the first one, we didn't test the second or the third. So having smaller tests like this and a single assert statement allows you to determine much faster when things are wrong. So you don't have the 99 errors and bugs in the code song, take one down, pass it around, 173 errors and bugs in the code. The fact that you fixed one bug reveals that there were more bugs that couldn't have even found the light of day until this bug was fixed. It's the same thing with tests. If your first assertion fails and your second and third and fourth would, you're not gonna be able to tell that until you fix what was causing the first assertion to fail, and then only now can the second assertion fail. If you had a bunch of different tests, you might be able to see that all of those failed in parallel. So no knowledge about whether later assertions would have failed. Tests should avoid logic. Don't use ifs, else, loops, switch cases. No logic, just set up the problem, run the method, check. So it should be, each test should be very short, self-contained. We're basically out of time. Don't try catch in your tests. So we'll come back to this a little bit and move on to stuff that you will need for the second sprint. Starting Thursday. But hopefully, if you hadn't seen this before, this helps you to get started thinking about writing tests. And adding some tests to your code. This will start to be a requirement in the next one.
So they're gonna be.
Yeah.